Dear Gage, who is Sir Isaac Newton and what are his three laws of motion? Well, that is a very good question, whoever threw this weird paper ball.
Sir Isaac Newton is a physicist who lived back in the 1700s who made three laws of motion. The first law is the law of inertia. Let's talk about that. So basically, the idea of inertia is that an object will stay at rest or stay at motion unless acted upon by an outside force. This means that, say this ball right here, is going to stay still unless something else makes it move, like this. In the law, it also states how it's going to stay in motion, so you would think the ball would just keep rolling forever. But that's not true in this case, because there are other forces acting on it, like friction, air resistance, it bumps into something. That's why things don't continue rolling or moving forever. Basically, a way of putting this is, every object in the universe wants to continue doing what it's already doing, like staying still or moving, but some things prevent that from happening. Like take this shoe right here, alright? It's staying still, it wants to stay still, but an outside action happens, and it moves. Let's move on to Newton's second law. His second law states force equals mass times acceleration. This means that to find the amount of force to move something, you would need to know its mass to get a certain acceleration. And the heavier the object is, the more force is required to move it. Like, if you wanted to drop kick a stroller 5 feet, you would have to exert X amount of force, right? But if you wanted to drop kick a rhino X amount of feet, then it would take more force because it's heavier, it has more mass. Let me give you an example.
Take these two things for example. This is a roll of paper towels, and this is a small can of paint. I'm going to use the same force, close to the same force on both of these, and watch. Alright, see? Knocks over easy, and this one, it just kind of budges. This is because the can of small paint has more mass and weight than the roll of paper towels. See this, I could just, and this, maybe knock it over, right?
This is the example of what I meant, like drop kicking something. The heavier an object or the more mass an object has, the more force is required to keep it at a certain acceleration or accelerate it. Like the roll of paper towels, it was like 10 times lighter than the can of paint. So it was really easy to just smack it as far as I wanted, but with the can of paint I had to use a lot more force, and it would probably hurt my hand to smack it because it had more mass and more weight. Now it's time for Newton's third law. His third law states that for every action, there is an equal or opposite reaction. This means that for every force that you apply to anything, there is going to be an equal force pushing back. Sometimes the force that you exert can be stronger than the force that is exerted. It depends on the object. Like, if you get a thin wall and you punch it, you would probably be able to punch through it, because that wall does have an opposite reaction, but it's not as strong as your action force. But if you go up to a brick wall and punch it, you'd probably break your hand. This is because depending on how hard you punched it, it has a greater reaction force, but it's still exerting the same force you had. It just has the same reaction force, so it's probably going to send that force right back into your hand and you're going to break it. Let me give you an example of Newton's third law. Follow me.
Alright, so you see this teddy bear, right? It probably won't have that good of a reaction force because nothing is supporting it and it's super fluffy. And I have this bat, which has a really good action force against this. So, let's see.
Alright, let's test this out. My studies are not completely concluded, so I may have to run that a couple more times. Alright, so Mr. Teddy is fine, so you don't need to worry about him, and I didn't hit him any more times than the one I needed, and he's a tough little cookie, so he can take it. But as you could see in that example, my bat that I used had a greater action force than this teddy bear could withstand. Now, there still was a reaction force that was exerted from this. That's why I had a little bit of resistance when I swung it. If it didn't, then I would have just been able to go clean through. And I kind of did, but there was resistance. That's why if I were to do the same thing, but with a brick, the bat probably would have stopped and bounced back, depending on how heavy the brick was. All right. Thank you guys for watching, and that's Newton's 3 laws. Swear to God, Mom. Well, that's not gonna work. Let's move on to Newton.